When you have two conduits entering opposite sides of a T-fitting and the short conduit length, less than 24 inches, extends from the T into an enclosure, panel, or cabinet, the crucial question arises whether this short piece is considered a nipple or a part of the continuous conduit run. This determination impacts the allowable conduit fill and ampacity adjustment requirements. Based on the National Electrical Code, specifically Article 358.40, this short conduit section is considered an extension of the raceway, not a nipple. As an extension of the raceway, the 60% fill allowance, which is typical for nipples, and the exemptions from ampacity adjustments do not apply. In other words, you must adhere to the standard conduit fill requirements outlined in Chapter 9, Table 1 of the National Electrical Code and apply ampacity adjustments as needed per 310.15. Now, let us examine how the scenario changes when a properly sized junction box is used instead of a T-fitting at the intersection of the conduits. According to Article 314, outlet, device, pull and junction boxes, conduit bodies and fittings must be of sufficient size to provide free space for all enclosed conductors. The critical difference lies in how the code treats conductors passing through an enclosure versus those within a continuous raceway. When using a properly sized box, the conductors passing through the enclosure are no longer considered to be within a continuous raceway for the entire run. Instead, the box serves as a transition point. The fill requirements are governed by box fill calculations as detailed in Article 314.16. In this case, according to 358.12, the conductors within the enclosure itself would be considered to be in a raceway, and the 60% fill and no ampacity adjustment exceptions would apply. This exception means you could potentially have a higher conductor fill within that short section of conduit entering the enclosure from the box, provided it meets the requirements for nipples less than 24 inches. To summarize, firstly, a short conduit section connecting a T-fitting to an enclosure is treated as a raceway extension requiring standard conduit fill and ampacity adjustment calculations. Secondly, using a properly sized box at the intersection creates a transition point, and the conduit entering the enclosure can then be treated as a nipple, potentially allowing for a 60% fill. Thirdly, always refer to the specific articles in the National Electrical Code, such as 358.40 and 358.12, to ensure accurate and compliant installations. Understanding the distinction between nipples, raceway extensions, and the role of junction boxes is crucial for adhering to the National Electrical Code. Failing to do so can lead to code violations, overheating of conductors, and potentially hazardous situations. Always consult the latest version of the National Electrical Code and seek guidance from a qualified electrical inspector when in doubt. Correct application of conduit fill requirements and ampacity adjustments is paramount for electrical safety and system reliability. The implications of misinterpreting these rules can be significant, leading to unsafe installations and potential equipment failure. Let's delve further into the practical application of these rules. Imagine you are running 3 number 10 American wire gauge THHN conductors through a 1/2 inch electrical metallic tubing conduit. According to Chapter 9, Table 4 of the National Electrical Code, a 1/2 inch electrical metallic tubing conduit can accommodate up to 4 number 10 American wire gauge THHN conductors based on the standard 40% fill allowance for more than 2 conductors. However, if this conduit section is an extension of a raceway as previously described, then this fill is what you need to follow. Now consider if you were using that same 1/2 inch electrical metallic tubing conduit as a nipple, no more than 24 inches in length, between a properly sized box and an enclosure. In this scenario, you could potentially fill the conduit up to 60%, as permitted by the exception for nipples. Always consult the relevant tables and examples in the National Electrical Code to ensure accurate calculations. In addition to conduit fill, it's crucial to consider ampacity adjustments. Ampacity refers to the current carrying capacity of a conductor. When multiple current carrying conductors are bundled together in a raceway, the heat generated by each conductor can raise the overall temperature within the raceway, potentially exceeding the conductor's insulation temperature rating. To mitigate this, the National Electrical Code requires ampacity adjustments based on the number of current carrying conductors in a raceway. These adjustments are found in 310.15. However, the exception for nipples also applies to ampacity adjustments. If the short conduit section is considered a nipple, no ampacity adjustment is required, provided it meets the code's requirements for nipples. Now, let's talk about properly sized boxes. Determining the appropriate size for a junction box involves calculating the box fill, which is the total volume occupied by conductors, devices, and fittings within the box. Article 314.16 of the National Electrical Code provides detailed guidelines for box fill calculations. Factors that contribute to box fill include the number and size of conductors entering the box, the number of devices such as switches and receptacles, and the presence of fittings like cable clamps. The box must be large enough to accommodate all of these components without overcrowding, ensuring that conductors are not subjected to excessive stress or insulation damage. Using the incorrect box size can lead to code violations and potentially dangerous conditions. It's also important to note that the definition of a nipple, as it relates to conduit fill and ampacity adjustments, is generally understood to be a short section of conduit, typically no more than 24 inches in length, used to connect two enclosures or boxes. This definition is not explicitly stated in the National Electrical Code, but it is a common interpretation based on industry practice and the intent of the code. Understanding the nuances of these rules requires careful attention to detail and a thorough understanding of the National Electrical Code. It's always recommended to consult with a qualified electrical inspector or engineer if you have any questions or doubts about the correct application of these requirements. In addition to the specific articles mentioned earlier, it's also important to be familiar with other related sections of the National Electrical Code, such as Chapter 3, Wiring Methods and Materials, which covers the requirements for different types of raceways and conductors. Furthermore, Chapter 9 provides tables and examples for conduit fill calculations, conductor properties, and other relevant information. Staying up to date with the latest edition of the National Electrical Code is crucial for ensuring code compliance. The National Electrical Code is updated every 3 years, and changes are often made to address new technologies, installation practices, and safety concerns. Subscribing to electrical trade publications, attending industry seminars, and participating in continuing education courses can help you stay informed about the latest code updates. Remember, electrical work can be dangerous if not performed correctly. Always follow safety precautions, wear appropriate personal protective equipment, and de-energize circuits before working on them. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job. The National Electrical Code is a complex and comprehensive document, and it's not always easy to understand every aspect of it. Don't hesitate to seek help from qualified professionals when needed. By taking the time to learn and understand the code, you can ensure that your electrical installations are safe, compliant, and reliable. The proper installation of electrical systems is essential for protecting people and property from electrical hazards. By adhering to the National Electrical Code and following best practices, you can contribute to a safer and more efficient electrical environment. So, the next time you encounter a short conduit section, remember to carefully consider whether it's a raceway extension or a nipple, and apply the appropriate fill and ampacity adjustment rules accordingly. And always prioritize safety and code compliance in all of your electrical work. This detailed explanation should provide a solid understanding of conduit fill, ampacity adjustments, and the distinction between nipples and raceway extensions, empowering you to make informed decisions in your electrical installations.